Hello, and welcome back to Forensic Bites and our series on instrumental methods in forensic science. Today we're going to be talking about what instrumental tests are needed to characterise unknown illicit drug samples. What we're going to be covering is SWGDRUG, or the Scientific Working Group for the Analysis of Seized Drugs. We're going to go into the SWGDRUG characterisation of different analytical identification techniques, as well as the logic behind the assignment of different instrumental techniques to those categories. Finally, we're going to discuss the minimum SWGDRUG recommendations for identifying an unknown suspected illicit drug sample. So to start with, what is SWGDRUG? Well, I've already gone through what the acronym stands for. It's the Scientific Working Group for the Analysis of Seized Drug Samples, and it seeks to improve the quality of forensic science as well as provide some standardization of different analytical methods for drug samples. It's an American working group and it has affiliations with the Drug Enforcement Agency, or DEA. That said, from its inception, it sought international input as well as international acceptance of the criteria that it proposes. And the website for SWGDRUG is shown here. If you actually go to that website, you'll find various resources. Some really good ones include illicit drug monographs. So that's a combination of different characterization outputs, such as reference data for illicit drugs, which includes NMR spectroscopy, mass spectra, infrared spectra. So to dig down into that, the infrared spectral library contains 624 illicit compounds. The mass spectrometry library contains the spectra of more than 3,500 compounds, as well as information on opioids, characterizing uncertainty, different types of references and literature available. Also, there is their own document library, which includes up-to-date practices and recommendations based on the working group's findings. SWGDRUG proposes three categories for the different types of analytical instrumentation used in forensic laboratories. At the top is Category A, and these methods provide unambiguous structural assignment of the unknown chemical sample. The downside of Category A is that these techniques often require pre-purification of the samples, so they don't have any inbuilt purification methods. So you can think of this as unambiguous qualitative analysis. It will provide you with data that only corresponds to the illicit drug and nothing else. Category B can also provide a structural assignment, but only in comparison to a known standard. So a good example would be liquid chromatography. If you run an unknown sample, you can characterize where that peak will appear in the chromatogram, and if you run an analytical standard of what you suspect the illicit drug to be, it will also appear with the same retention time. Now, the good thing about Category B techniques is they often have the ability to purify samples. So if you have a mixture of samples, they can separate out the mixture, and they can also give you information about the purity of your sample, should it be a mixture. So Category B can be likened to quantitative analysis. Final category is Category C. This provides information about drug class characteristics only, and it's particularly good for initial screening of drug candidates, as well as just trying to figure out what further analyses you want to do. So particularly given that Category A and Category B are more expensive in terms of cost and time, Category C allows you to quickly assign what your illicit compound may be. So to focus more on Category A, here are some of the leading instrumental techniques used in analytical chemistry. So if we look on the right, we can see infrared spectroscopy, mass spectrometry, nuclear magnetic resonance spectroscopy, Raman spectroscopy, and X-ray diffractometry. So all of these methods will provide you with unambiguous assignment of a chemical unknown species. Of these methods, some are more suited to integration with quantitative methods, so basically Category B methods, whereas others are not. So the best example in the list is mass spectrometry, which can be interfaced with Category B methods, such as gas chromatography or liquid chromatography. It's very hard to integrate the other methods out there, so infrared, NMR, Raman, and X-ray. All of those methods you would struggle to link that to some form of chromatography, which allows you to separate out mixtures. So of the 5 shown, mass spectrometry, I would say, is the most useful in a forensic setting unless you are dealing with highly pure samples. So samples with no adulterants, they haven't been cut with any other cutting agents. You could theoretically use some of these other methods to analyze mixtures, but then you would need a library of mixtures with known compositions. And practically, that's just not particularly feasible. Moving on to category B, these methods are typically comparative techniques that are often performed against an analytical standard of a known drug. So let's say you have an unknown sample, you suspect it's cocaine, you run liquid chromatography, you would run that comparing against a known cocaine analytical standard, in which case they should both give chromatograms with matching retention times. Many category B techniques offer a means of separating complex mixtures, which is another way of saying they often involve chromatography. So examples include gas chromatography, liquid chromatography, thin layer chromatography, as well as some of the other separating techniques like capillary electrophoresis and ion mobility spectrometry. Many of the methods I've just mentioned can be coupled to a mass spectrometer, thereby creating a combined category A, category B system. The last category is category C, and these tests typically rely on some physical characteristic in the sample, such as its melting point. These characteristics, though, can be shared across many different chemical structures, especially near structural analogues, so those with related chemical structures. Because of this, they present a number of false positives, which is where a illicit compound will give the same response as an illicit compound, and you can't distinguish between the two. Good example of that will be the colour tests, whereby you get a colour change usually based on the chemical functional groups present in the illicit drug. However, many chemicals could contain those same functional groups and thus give you a similar response by the colour test. If we look at melting point, there are many different chemical species that share the same melting point. So because they would all melt at the same time, you have the key drug that you're looking for, as well as many false positives that would melt in the same range. So how do you make an identification based on all of these different categories and analytical methods? According to the minimum SWGDRUG standards or guidelines, a forensic identification requires an unknown seized drug sample to be analysed by either one category A technique, like mass spectrometry, combined with corroborating data from either a category B or a category C technique. So talking about before, the combined mass spectrometry with a technique like gas chromatography or liquid chromatography, those two things together would give you a category A combined with a category B result. The other identification method could involve two category B techniques, which is combined then with a corroborating category C result. So a positive presumptive test, and that's combined with maybe gas chromatography and capillary electrophoresis. So those three techniques combined together would give you an unambiguous assignment of your unknown illicit drug. First option, whereby you use a category A, you only need two instrumental techniques that support one another. Or if you're not using a category A technique, you need two category B techniques as well as a category C result. So it's either 3 tests or 2 tests, depending on whether or not you've used a category A technique. All the data from category A or category B must be reviewable. So you need to be able to provide that data and it needs to be scrutinized. You also need to preclude false positives if, for example, you're using a category C test. And if you combine category C with category B or category A, you are going to be able to preclude that, because the more discriminatory techniques will allow you to weed out false positives from other chemical species. So to conclude, there are many combinations of techniques that could be used to identify suspected illicit drug samples. SWGDRUG guidelines has grouped the analytical techniques into 3 categories based on their discriminatory power. The different combinations of categories are used for identification, which at minimum must include either a category A test or 2 category B tests, usually supported by a category C presumptive test. And in a forensic laboratory, GCMS or LCMS is the most common combination analytical technique that combines Category A and Category B. Thanks again for listening, and please check out some of our other videos.